What's up everybody and welcome to a new video. In the previous video we took a first look at the game that we're going to create in the series, and we've also covered the disclaimer and then here this to-do list. And now in this video we're going to start to create this game, and therefore we're going to start with the basic game mechanics, and more specifically we're going to start with the helper functions. Namely, we're going to need a function that creates a grid, a function that prints out the grid, a function that executes a move on the grid, and then lastly a function that checks if four dots are connected. So let's start with the function that creates the grid, and we're going to represent the grid by using simply a list of lists. So here we have this outer list which contains these 6 inner lists. So 6 inner lists here represent the rows of the grid. Then each inner list here has 7 elements. So those are representing the columns of the grid. And then each element here is simply a string with a space, which then is going to represent an empty cell. And now the way that we're going to create this grid is by using a list comprehension. So if you don't know what list comprehensions are, then I also have a video about that. So I will put the link to that video into the video description. So now let's just use a list comprehension to create here this grid. Namely, we're going to start by creating this outer list, which contains these 6 inner lists. So therefore, we're simply going to say for underscore in range 6. And then here, what we want to have is we want to create those inner lists. So if I run it like this, then we get here this outer list containing those 6 inner lists. And for those inner lists, we can again use a list comprehension. So this time then we want to create those 7 elements. So we're going to say for underscore in range 7. And then here we simply want to create our string, which contains the space. So if I run it like this, then we get here our grid. So this is what the code could look like. However, I want to get rid of these magic numbers here, and therefore I'm going to create some constants. So the first one I'm going to call n rows. This we're going to set equal to 6. The next one is going to be called n columns, and this will be equal to 7. And then I would also like to replace here this string with a constant. So this I'm going to simply call empty cell. And this is going to be a string with a space. So those are the constants. So now let's replace those magic numbers with those constants. So the 6, and then also here this 7. And then lastly also here this string. So this is now what our code looks like. So let's put it into a function. So let's simply call this create grid, and then the function should simply return that list comprehension. So this is what our function looks like. So let's now copy this code into this helper functions.py file. So therefore let's create here a comment that says constants, and then let's also create a comment for the functions, and here then we're gonna put in this function that we've just defined, and with that then we've created our first helper function. So therefore then we can check off here this first point in our to-do list. Then the next function should print out the grid. So therefore to create that, let's first import here this helper functions.py file into our notebook here. So we're going to say import helper functions as hf. And then we're going to create the grid. So we're going to say grid equals hf.create grid. And now one thing that we could do to print out the grid is to simply say print grid. However, if you do that, then the rows are not here depicted underneath each other. So therefore to get around that, what we're going to say is for row in grid. And then we're simply going to print each row. So we're going to say print row. So if I run it like this, then we get here this nicely looking grid. And now one thing that I would like to add to that is some column headers. So I would like to indicate that this here is column 1, this is column 2, this is column 3, and so on. Because that way then the player doesn't have to count what column he or she wants to play. So therefore, let's add here another print statement. And here we're going to print a string. And first we're going to add in here 2 spaces and then a 1. Because if I do it like this, then this 1 here is depicted exactly above column 1. So then let's also do that for the other columns. And here then we need 4 spaces. And then here, if I put in a 2, then if I run it like this, then a 2 is again depicted exactly above column 2. So also, let's also do that then for the other columns. So for column 3, column 4, column 5, column 6, and lastly column 7. So if I run it like this, then we have now these column headers. And now one additional thing that I would like to add is some more space before and after the grid. So therefore we're simply going to add another print statement, and here we're going to print an empty string. So we're going to print an empty line, and that we're also going to do after the grid. So here also let's print an empty string. So then the output looks like this. So this is now what our function is going to look like. So let's put this code here into a function. So let's simply call this show, and then we're going to put in the grid, and then let's indent this code here. So this is now what our function is going to look like. So let's copy this here now into our helper functions.py file. And with that, then we have created our second helper function, and therefore then we can here check off the second point in our to-do list. Then the next function is for executing a move on the grid. So let's simply call this function make move. And the information that we're going to need for this function is the current grid, the current player, and then also what column that player wants to play. So for now, let's just put in here a pass. And now to demonstrate how this function is supposed to work, let me print out the grid again. So let's say here hf.show grid. And then let's say that the current player is player X. So we're going to start off with players X and O. And then let's say that the column that the player wants to play is column 2 here. So therefore then we have to use index 1 because we have a 0-based index. So if we want to make a move here in this position, then the notation is as follows. So we have to say then grid brackets, and then here we have to specify the index of the respective row. So the index of this top row here is index 0, and the index of this bottom row here is 5. So therefore then we have to use here a 5. And this way then we access here this inner list. And then here we have to specify the index of the respective column. So therefore we're simply going to use here this column variable. And then this way then we access here this position. And then we're going to say that this should be equal to the player. So then let's also print out the grid again to see if that worked. So let's say here hf.show grid. And then here you can see we made our move here in column 2. And then let's say in the next move, the player wants to again play column 2. In this case, then we obviously can't make our move here in this position because there's already a move been made. So therefore then we have to go one row above that and then make our move here in this position. So therefore then we have to use here index 4. So if I run it like this, then we made our move now in this position here. So what it means now for our function here is that based on the column that we get here, what we want to do is we want to go to the bottom row and then check if that respective cell is empty or not. If it is empty, then we can make our move. If it is not empty, like it's the case here on column 2, then we have to go one row above that and then again check if the respective cell is empty or not. And again, it's not empty. So therefore we would then go one row above that and then make our move here. So the way that we achieve this is by saying for row in range n rows. So if we would write the for loop like this, then we would actually start here at the top row and then go down. However, we would want to start at the bottom row and then go up. So we want to do it in the reverse order. So therefore we simply say then here reversed. And then what we want to do is we want to check if the respective position is equal to an empty cell. So we're going to say if grid brackets row brackets column, if that is equal to this empty cell that we've defined here, then we want to make our move. So then we can simply copy here this part of the code. And then we're going to say that this should be equal to the player. And if we want, or if we then made the move, we simply want to return the grid. So this is what happens when this if statement here is triggered. If it is not triggered, then we simply go to the next iteration here of this for loop, i.e. we move one row up. So this is now how our function is defined. So now let's test it. So therefore, let's recreate here the grid. And then here we're going to say make move. We put in the grid, and then the player is X, and he wants to play column 1 again. So then let's print out the grid again. So let's say here href.show grid. And then if I run it, then you can see we made our move now here in column 2. So now let's see what happens if we run this function again. So therefore then the move should be made here in this position. So let's see what happens. And if I run it, then you can see we made our move now in this position. And if I run it again, then now we made our move here. So now let's just quickly test another column. So let's pick here column 6. So that has index 5. So if I run it, then you can see now we made our move here in column 6. So our function is working. So let's now copy this into our helper functions.py file. And with that, now we've created here our third helper function. And therefore then we can check off here the third point in our to-do list. And then the last function is for checking if 4 dots are connected. And they can be connected in 4 different ways. They can be connected horizontally, vertically, and then also in the diagonal right or diagonal left. So let's start with checking if they are connected horizontally. So therefore, let's create here another function. And let's call this is for connected. And then here we're going to pass in a grid. And for now, let's just again write here pass. So now to demonstrate how this function is supposed to work, let me again print out the grid. Namely, what we're going to do is we're going to create a moving window. So let's see how that moving window behaves when we check if 4 dots are connected horizontally. Namely, the first window that we then going to create is this one that goes from column 1 to column 4. So then we have here these 4 positions. And then we simply check if 4 dots are connected or not. And if that's not the case, then we move this window 1 position to the right. So then the next window is going to be this one. And again, if not 4 dots are connected, then we move it 1 position to the right. So this would be this one. And then the last window in this first row would be this one, going from column 4 to column 7. And then we simply do the same thing over for the second row. And obviously we also do that for all the other rows. So now, in order to achieve that, what we're going to say is for row in range n rows. And that's because we have to check all the rows here. And then for the column, however, we're going to say for column in range 4. And that's because we only have to check the first 4 columns. And that's because when we get here to column 5, there are only 3 positions left. So here we can't create a window with 4 positions. So that's why we use here 4. And then again, to not use here a magic number, let's create another constant for that. So therefore, let me here split the editor and then move this here to the left. Then I'm going to scroll up, and then here I'm going to create another constant. So let's call this first 4 columns, and this is going to be equal to 4. So let's use this constant here in our for loop. And then within the first iteration of these 2 for loops, we are then here at this position. And then here we have to access those 4 cells. So we have to say something like cell 1 equals grid brackets row brackets column. So that would be then here this first cell. And then to get the second cell, we simply have to increase our column here by 1. So let's copy this line and then say here cell 2 equals and then column plus 1. Then to get here cell 3, we simply have to increase the column here by 2. So let's again copy that and then say here plus 2. And this is then cell 3. And for cell 4, we simply have to then increase the column by 3. And then here for cell 1, this here is basically the same as saying plus 0. So actually, we can also create those 4 cells here within another for loop. And here we're going to store those cells in a list. So then we're going to say cells equals a list. And then here we say for offset in range 4. So that we get here these offsets. And again, to not use here a magic number, let's create another a constant, and this is going to be called n cells. This is equal also to 4. So let's use that here. And then just like we did here, we're going to create here then a cell. So we're going to say cell equals this. And here, instead of saying +0, we're going to say plus offset. And then we simply append this cell to this list here. So we say cells dot append cell. So that's now our code for the moving window. So let's see if that is actually working. So therefore, let's make a move, so to say, here in this for loop. So we're going to say that this should be equal to x. And then after the for loop, we're going to print out the grid. So we say href.show grid. And after that, we're going to reset the grid by saying href.create grid. And that's because, so that we then have in the next iteration of these two for loops, that we then have a new grid. And then here, let's just add another print statement where we add here the separator between the different grids. So now let's run this to see the moving window. So let's scroll up and see if that is working as expected. So here, the first moving window is this one. And then the next one is moved one position to right. Then again, this one is moved one position to right. And then the last one in the first row is this one. And then we do the same thing for the second row, the third row, the fourth row, the fifth row, and then lastly the sixth row. So as you can see, our code is working. So let's therefore comment this out again, because we're going to need it later on. So then once we have created those 4 cells, what we need to do is we need to check if all the elements here in this list are the same. So therefore, to see how to do that, let's create such an example list. So let's put in here 4 x's. Let's say here x, x, and x. And now the way that we're going to check if all these elements in this list are the same is by simply looping over this list and then checking if the respective element is the same as, for example, the first element in this list here. And therefore we can again use a list comprehension. So we can say for cell in cells. And then here, what we want to do is we want to check if that cell is equal to, for example, the first element in this list. So we're going to say cells brackets 0. So now if I run this, we get here true, 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 because all the elements are the same. However, if I make this now here an empty cell, for example, then we get here true, false, true, true. So this list comprehension is working. So now let's store this into a variable called cells same. And then let's also print out this variable again. And now to check if all the elements in this list here are the same, we can, for example, we can calculate the sum of this list. So we can say sum of cells same. Then in this case, we get a 3. So that means that all the elements here in this list are not the same, because if they were the same, then we have here 4 truths, and then our sum should be 4. So for example, if I make this here now an x again, then we get 4. So that means all the elements in this list then are the same. So that's one way of doing it. Another way would be to use here this built-in function all. So what that does is it returns true if bool of x is true for all values x in the iterable, i.e. if all the elements here in this list are true, then this function should return true. So let's see if that's the case. So we're going to say here all cells the same. And then here we get a true. And now let's make this here again an empty cell to see if it then returns a false, and it does. So our code now is working. However, there's one edge case, namely if all the elements here in this list are empty, then all the elements are also the same. So therefore then we also get here a true for this all function, and that's not what we want. So therefore we're going to add another condition. Namely, what we're going to check is if this empty cell is not in this list. So there should not be an empty cell in this list here. So we're going to say empty cell not in cells. So if I run it like this, then we get now here a false. So now let's see if it also works when we get here, when we have 4 x's. So now we should get a true again. And as you can see, we get a true. So now our code here is working, and we can then copy it into our is4 connected function. So let's do this. So let's first here copy the moving window. So therefore, let's then indent this. Then we're going to use here this cells same variable after this for loop. And then after that, we're going to check if all the cells are the same and empty cell not in cells. So if that's the case, then we're going to return a true. Otherwise, what we're going to do is simply return false. So if this if statement here is never triggered, then this function is going to return a false. So this is now our function. So let's see if that is working. So therefore, I've prepared here this grid. So let's put this grid into this function. So let's say here is for connected, and then we put in the grid. So now right now we get here false because there are not 4 dots connected. So now let's add here some x's. So if I add here just 3 x's, then we still get a false. However, if I now put in here a 4th x, then we should get a true. So if I run it, then we get here a true. And our function now is working for the case that there are 4 dots connected horizontally. So therefore then we can check off here this point in our to-do list. So now let's add a check to see if 4 dots are connected vertically. And therefore let's again first have a look at how the moving window behaves. Namely, again, we're going to start at this position, but this time instead of creating the moving window to the right, we're going to create it down. So therefore then here when we are at this position, we're going to consider this position or this cell, and this cell. And if not 4 dots are connected, then we are moving to the second column and then do the same thing. And we do that then for all the columns. Then we go 1 row down. And then in this case, we're going to consider this cell, and this cell. And again, we do that for all the columns. And then lastly, the last row that we're going to consider is here the 3rd row. And then we're going to consider those cells here. And then we do that again for all the columns. And then here for this 4th row, we can't use that because there are only here 3 positions left. So in our code here, what we're going to do is instead of saying for row in range n rows, so we're not considering all the rows, we're only considering the first 3 rows here. And again, to not have a magic number, we're going to create another constant. So let's simply call this then first 3 rows. And we're going to set that equal to 3. So let's then use that here. And then here, instead of saying for column in range first 4 columns, we're actually going to consider all the columns. So here then we're going to say n columns. So that's the first change that we need to make for those 2 for loops here. And then the other change that we need to make is here when we create the cell. Namely, for the horizontal check, we needed to add the offset to the column. However, now for this vertical check, what we do is instead of going to the right, we actually stay in the same column. And then, however, we go down. So we have to add the offset here to our row and not to the column. So this is now already, these are only all the changes that we need to make. So now let's see if this vertical window works. So therefore, let's again uncomment this part of the code. And then let's copy this section here with this one. And now let's run this and see if our vertical window is behaving correctly. So the first window that we have is this one. Then we move to the second column, third column, fourth, fifth, sixth, and seventh. Then we go 1 row down and then again do that for all the columns. And then again, we move 1 row down and then do that again for all the columns. So our code is working. So let's comment this out again. So now we have here our check for the horizontal check, and here we have our code for the vertical check. So now let's bring those two things together. So for the horizontal check, what we needed to do here in those first two for loops is here we need to use n rows and first 4 columns, whereas here we need to use the first 3 rows and then n columns. So let's now store this information into a dictionary. So therefore, we're gonna create another constant, and we're gonna call this starting positions. And this is gonna be a dictionary. And here the first key is gonna be a string that says horizontal. And here the value is going to be a list where we then store these two constants. So n rows, and the other one is going to be the first 4 columns. And then we do the same thing for the vertical check. So we're going to say here vertical, and we're also going to have a list. And in this list, we're going to use the first 3 rows. And we're going to use n columns. So that's the first change that we needed to make. So now let's use this dictionary here in our for loop. So therefore then let's indent everything here. And then here we're going to say for direction in starting positions. And then here we need to access those two values and store them into variables so that we then can use them here in those for loops. So we're going to say nth row, comma, nth column. This should be equal to starting positions, brackets, direction. So if the direction is horizontal, then the nth row and nth column are going to be those two constants here. If it is vertical, then they are going to be those two constants. And then let's use those variables here in our for loops. So we're going to say here for row in the range nth row, and then for column in the range nth column. And then the other difference was when we calculate here the cell. So therefore, what we're going to do is here in this for loop, we're going to say if direction equals horizontal, then we're going to add the offset to the column. So we're going to say then here row offset equals simply the row. So that's not going to change. And the column offset is going to be column plus the offset. And then for the vertical check, we're going to do it the other way around. So let's copy and paste it. So here we're going to say else if the direction is vertical, then we're going to add the offset to the row. And then we're simply going to use here the row offset and the column offset when we are creating here our cell. So that's now already all the changes that we needed to make. So now let's see if this code actually creates the moving windows for the horizontal check and the vertical check. So therefore, let's again here copy this part of the code. And then let's run this to see if it is working. So let's scroll up. So first we have here our horizontal check across all the rows. So that seems to be working. And then here we have our vertical check across all the columns. So that is also working. So again, let's comment this out. So with that, now we have created code that checks if 4 dots are connected horizontally or vertically. So let's now copy this code into our function here. So we only need to replace this part of the code. And then let's indent everything here. So let me just check. So now this should be working. So now if we check this function for this grid here, we should get a true, and we do. So now let's change this here to an empty cell again. So then we should get a false. And now if I connect here 4 dots vertically, then it should again give us a true. So let's see if that's the case, and we get here true. So now our function checks if 4 dots are connected vertically and horizontally. So therefore, let's then check off here this next point in our to-do list. So now let's add a check to see if 4 dots are connected in the diagonal right direction. So therefore, let's first again think about how the moving window should behave. So again, we start here at this position, and then the positions or the cells that we're going to consider are this cell, and this cell. Then we move to the next column. Then we're going to consider this, and this cell. Then we move to the next column, so the third column. Then we're going to consider this cell, and this cell. And then lastly, we go to column 4 and then consider this cell, and then this cell. And then here for column 5, there are only 3 positions left, so we can create a window with 4 positions. So again, we are only going to consider the first 4 columns. Then we go to the next row and then do the same thing for the first 4 columns. Then we go to the third row, again do the next thing, do the same thing for the first 4 columns. And then here for the fourth row, we are actually only again just having 3 positions. So again, we are only considering the first 3 rows. So now let's store this information here in our starting positions dictionary. So here then we're going to say diagonal right. And this should be then a list. And the first element is this list is then that we want to have the first 3 rows. And then we want to have the first 4 columns. So that's the first change that we need to make. And then here we simply need to add another else if statement. So let's do that. So here we're going to say if the direction is equal to diagonal right, then we want to do the following, namely when we are at this position and then want to add this here, then therefore we have to increase the column and also increase the row. So we have to add this offset here to both. So we have to say row plus offset and column plus offset. And these are already all the changes that we needed to make. So now let's see if that is working. So therefore let's uncomment this here again and then see the moving window. So let's scroll up again. So first we should have here the horizontal check. So we have that. After that comes the vertical check. So here we have our vertical check. And then after that, we now should have our diagonal right check. So here's the first diagonal right window, then the next one, then the next one, and then the next one. And then we go 1 row down and then do this again for the first 4 columns. And then again, we do that, or we go 1 row down and then do this again for the first 4 columns. So our code is working. So let's comment this out again. And then let's simply copy this else if statement here into our function. And now our function should work and it should make a check for the horizontal direction, the vertical direction, and the diagonal right direction. So again, let's here run this again. And here we get a true because these 4 are here connected. So let's make this here now an empty cell again. Then we get a false. And now let's connect 4 x's in the diagonal right direction. So let's make this an x and then this one. So now we should get here also a true. So let's see if that's the case. And as you can see, we get here true. So now our function is working for these 3 different directions. So therefore then let's check off this point in our to-do list. And now lastly, let's also add a check to see if 4 dots are connected in the diagonal left direction. So therefore, let's again think about how the moving window should behave. So in this case, namely, we can't start at this position because there are no cells in the diagonal left direction. So we can only start here at column 4 because then we can consider this cell, and then this cell. And then we go to the 5th column and consider this cell, and this cell. And then we do the same thing for column 6 and 7. So for the case when we check in the diagonal left direction, we actually just want to consider column 4 to 7. And then we go 1 row down and then do the same thing over. So we're going to consider this cell, and this cell, and do that for columns 4 to 7. And then again, go to column 3 and then here do the same thing. So this cell, and this cell, and do that for column 4 to 7. And then again for column for row 4, we can't do that because there are only 3 positions here left. So for the case of the diagonal left direction, we're also going to consider only the first 3 rows. So now let's store this information here again in our starting positions dictionary. So we're going to say diagonal left And then here we also want to have a list. So we're going to consider the first 3 rows. And then here we have a little problem, because what we want to do is we want to consider columns 4 to 7. So we would need something like a tuple here where we have then 3 and 7. However, this would then throw an error, because here in our code, in this for loop here, where we say for column in range nth column, here we would put in here this tuple, and this then would throw an error. However, we can get around this by using a feature called unpacking, and I've already made a video about that. So if you don't know what that is, then I will put the link into the video description. However, let me just quickly show you what we can use that for. Namely, therefore, I'm going to create here a variable called columns, and this is going to be a tuple with 3 to 7. And then here I'm going to say for I in range 3 to 7. Then here I simply want to print I. So if I run it like this, then we get here the result 3, 4, 5, 6. And now let's say that I want to use, or that I don't want to use here these numbers, but instead I want to use here this columns variable. So the one way that I could do that is by saying then columns brackets 0, and then columns brackets 1. So if I run it like this, then we get here the same result. However, we can do that more easily by using the unpacking feature. Namely, what we can do is we can simply put in here our columns variable and then put a star in front of that columns variable. And what that will do is it will unpack these values here into this function call. So if I run it like this, then we get here the same result. And the good thing about this is that if there is just, for example, one value in this tuple here, then this will throw an error, because then this one value is simply unpacked into this function call. And in that case, then we get the following result, where we simply print out 0, 1, and 2. And now we can make use of this feature in our code here. So therefore then, let's finish here this tuple here. So here we want to consider column 4. So we want to start at column 4. So therefore, let's create here a new constant. So we're going to call this 4th column, and this is going to be equal to 3. So this is what we're going to use here. And then for the 7, we're actually going to use here this n columns variable. And then to not get an error for those other cases here, for those other directions, we also have to put those constants here into a tuple. So let's do that. So let's create here a tuple. And then here we need a trailing comma, because there's just one value. So now this is now what our starting positions dictionary looks like. And now here in our code for the moving window, we simply need to add another else if statement. So here then we're going to say diagonal left. And now let's think about what we need to do here. Namely, if we are, for example, at this position, then we want to add this here. So that means that we need to increase the row, but decrease the column. So here we're going to say row plus offset, and here we're going to say column minus offset. And that's already it. So now let's see if this moving window is still working. And therefore then we obviously also need to here in this for loop need to insert our star into this function call, so that we then unpack here this tuple. Okay, so now let's run this. And then let's see if the moving window is working. So again, we start with the diagonal window, then go through all the rows. Then we get to the vertical window and go through all the columns. Then we have our diagonal right window and go through the first 3 columns. And here then we have our diagonal left column, where we start with this window, or diagonal left direction, and then we start in this. We start with this window, then we move one to the right, and then here one to the right, and here, then one row down, and then again for those columns from 4 to 7, and then lastly for this row here, for the 3rd row, we have then these 4 windows. So as you can see, our code is working. So therefore, let's just copy here this else if statement into our is for connected function. And then here we also need to add this star. So this should now be working. So now let's test this. So here we have 4 dots connected in the diagonal right direction. So now let's simply remove here, for example, this X. Then we get here false again. So now let's connect 4 X's in the diagonal left direction to see if the function returns now true. And as you can see, we get here true. So now the function is working. So therefore then we can check off here this diagonal left point, and with that then we have created here this check if the 4 dots are connected. So with that then we've created all our helper functions. So now let's copy our code into our helper functions.py file. So let's copy first here the constants. So we're going to replace those constants here. And then lastly, we're going to copy our is4connected function into helper functions.py. And with that then we have now created all of our helper functions that we want to do. And with that now we've covered this first point here on our to-do list. So we've reached the end of this video, and then in the next video we're gonna work on the main game logic. So thanks for watching, and hopefully I will see you in the next video.